Good morning, good afternoon, and good evening, everyone. I wish to thank the organizers and the sponsors, Squared Up and Cookdown, for inviting me to give a presentation in this awesome global virtual event. The topic I am presenting today follows from what I've presented last year at SCOMathon 2021 and is entitled Fun with Advanced Native Dashboards in the SCOM Operations Console, Part 2. Here is a little bit about me. My name is Wei Hao Lim. You can call me Wei. I'm a senior customer engineer based in Melbourne, Australia. I've been in Microsoft for 10 years. I specialize in cloud and on-premise monitoring, data visualization, and dashboarding design, primarily leveraging SCOM, Azure Monitor, Azure Defender for Cloud, and Azure Cost Management. I work with a lot of enterprise customers to demonstrate the value of cloud monitoring services in Azure and SCOM, removing technical blockers and encouraging further customer confidence and adoption of these products and services. It is such an honor to be here today to speak to you all on this topic. Here is the agenda for today's session. The agenda is organized under the following topics. We will first do a quick overview of visualization features in SCOM and a quick recap on the basics of native SCOM dashboards and widgets. Then we will look at PowerShell methods that we can use to query configuration information of native dashboards, and an introduction to a custom widget that I have created called the Speedometer gauge widget. The objective of this session is to help provide information on the visualization features available in SCOM and the benefits that native dashboards provide. We will also look at how we can review and understand the configuration details of custom native widgets and dashboards created in a SCOM environment that can be useful for pre-migration or post-migration assessment and planning. Then I will demonstrate the features and steps to set up the Speedometer gauge widget in the Operations Console. This session will mainly focus on the native dashboard features in the SCOM console and utilizing PowerShell. So it would be great if you have some prior knowledge on the SCOM architecture. The core components of a management group is data flow using SCOM commandlets in PowerShell, familiarity with navigating the SCOM Operations Console, and also some experience with creating simple native dashboards and widgets in the SCOM Operations Console. In SCOM, there are many ways to display and visualize monitoring data using built-in features like views. For example, performance views, state views, or alert views. Dashboards, which allows you to present multiple types of data from different sources in a single view. There are two main types of dashboards in SCOM. The first type is the Operations Console native dashboards, which is the type we will be focusing on in our session today. And the other type is the Web Console HTML5 dashboard. Reports provided by SCOM reporting feature is installed on the server where SQL Server reporting services is installed. And alternatively, external tools like Power BI with data extraction from Operations Manager databases like the OpsDB or Data Warehouse database. The figure provides a comparison on when is best suited to utilize different visualization capabilities in SCOM based on how interactive you want the visualization experience to be and how much historical data is required to be displayed compared to how close to real-time the monitoring data display is expected. As shown in this diagram, SCOM native dashboards provide a good balance between interactivity, and also it allows monitoring data from different sources and time range to be accessed and displayed. So A SCOM native dashboard is made up of a layout, which consists of an arrangement of cells that can host content on components called widgets. Each cell in a dashboard can contain a single widget, and a widget can access a particular set of data or performs a particular function and presents its information in a dashboard. Each widget provides a specific set of customizations that can be modified accordingly. So dashboards can be defined and stored in management packs. That makes it very convenient to be shared, backed up, referenced, and their versions can be tracked as well. Here it shows that there are 5 basic steps to create native dashboards. The first step is to create a management pack to store the dashboard information and definition. Then choose a dashboard layout from the list of available out-of-the-box layouts. Then specify the name and the description. Add the widgets into each cell available on the dashboard layout which is used. You then have to click Save or Apply to store the settings and definitions of the dashboards and widgets to the management pack created or selected in the first step. A widget or layout is a component that can be added to a dashboard and configured in the Operations Console. Therefore, each widget or layout created in the Operations Console from the previous slide will be stored as a new component in the selected management pack in the component type section of the management pack XML. As shown in this slide, a component of a dashboard widget or layout consists of 3 main parts: the component type, component implementation, and component override. So let's say that we created 1 layout and 2 cells, with each cell containing 1 widget, and save their configuration into Management Pack A. Management Pack A will contain 3 sets of components each, with their 3 main parts for these 3 dashboard elements or components that we have just created. Another benefit of using native dashboards is that dashboards can show results from different sources in one single view and are highly customizable. Dashboards are really made up of 1 or more components, which are elements that can be a visual element, such as a list of alerts or performance graph, or data elements, such as a query. This example shows a sample custom dashboard identifying the different components that it consists of. This is to provide an illustrated concept of how multiple components make up a single dashboard. So this dashboard uses a PowerShell script to list SQL Server database objects with their health and free space. When the database is selected, its collected free space data is displayed in a graph, and its free space percentage is displayed in a speedometer gauge. As mentioned in the previous few slides, each component is defined by a combination of the following parts that are management pack elements. There are 3 main parts that we will be focusing on in this session. They are the component type, which declares the external interface of the component, including any properties that it requires. Next, the component implementation, which defines the detailed behavior of the component, and then is the component override. It is an override of 1 or more properties of an existing component that its parent, its component type references. These are the parts or management pack elements that are most relevant to the dashboard widgets and layouts created in the Operations Console. Here are some key points about dashboard components that relates to our next topic on utilizing PowerShell methods for native dashboards. Each custom dashboard layout and widget created from a template in the Operations Console references a base component defined in an existing library management pack. For each of these custom layouts or widgets, their property values are stored in the component override section of their respective component type definition. Therefore, a custom component references its base component, and its custom component override contains property values assigned to its base component type. Here is the full list of getComponent PowerShell methods that can be used to query configuration information of native dashboards. As you can see here, these methods are available for entities belonging to the Enterprise Management Configuration Management Pack data type. The getComponent override method and getComponent type method are the two useful methods that I will be showcasing in the demo part later. Here is an example of a PowerShell script that utilizes these two methods. As you can see on the first row, it starts from running the get SCOM management pack commandlet and returning all management packs that references the core System Center Visualization Library management pack. And yes, exactly, all custom management packs with native dashboard elements will reference the core System Center Visualization Library management pack. This is, of course, includes the management packs storing the custom dashboard widgets and layout created from the SCOM Operations Console. And more to be covered in the demo part later. Now, we look at some use cases to address why this knowledge on components, component types, component overrides, and PowerShell methods for native dashboards is useful. As shown in the previous slide, with the right PowerShell commandlet and methods, we can identify management packs with configurations and definitions of custom native dashboard widgets and layouts implemented in a particular SCOM environment. Here is the list of out-of-the-box widgets that can be created with pre-configured templates through wizards in the SCOM Operations Console. As mentioned, each custom dashboard widget created from these wizard-based templates in the Operations Console references a base component or widget type defined in an existing visualization library management pack. Therefore, the top few types of widgets used in a SCOM environment can be calculated by using the getComponent type method to find out what is the base component of these custom widgets. We can also find out how many custom PowerShell-based widgets are currently being used in the SCOM environment, and if these PowerShell scripts should be extracted and reused externally. For example, when migrating or upgrading to another SCOM environment, or planning to integrate with other dashboarding solutions or PowerShell-based automated systems. We can find out what are the other values assigned to the properties of the custom widgets for auditing or security purposes, where there could be PII type information stored within these properties that will need to be addressed. Here's an example of how to reuse a PowerShell script within a PowerShell grid widget of a native dashboard into a PowerShell widget of a dashboard in the HTML5 web console. Note that there are minor changes required as highlighted on the slide. That is to remove any string that matches the $ data pattern when reusing the PowerShell script in the PowerShell widget of the HTML5 dashboard. Another alternative is that if you are planning or are currently using SquaredUp, you could reuse these PowerShell scripts from native dashboard widgets in SquaredUp's PowerShell dashboards with its PowerShell integration capability. This will require some minor changes to the original PowerShell script. If you are interested to find out more about native dashboard components, more information is available at the TechNet Wiki site on Operations Manager Dashboard Management Pack authoring for custom dashboards. In this section, I will demonstrate how to use the PowerShell methods that we covered in the previous slides to extract configuration information of native dashboard widgets created in a SCOM environment. Now, I will demonstrate how to use the getComponent PowerShell methods to query configuration information from native dashboard layouts and widgets created in my SCOM environment. Here is my lab environment where we'll be doing this demonstration. I have created a folder up front that contains the resources for this demonstration. As shown here in this resources folder, I've prepared a text file with all the required PowerShell code to walk through in PowerShell ISE for this demo. I have also prepared a set of native dashboard layouts and widgets up front and have saved it in the SCOMathon demo dashboard pack. The set consists of 5 layouts: demo dashboard 1, 2, 3, 4, and 5. Each layout hosts a couple of widgets, from the PowerShell grid widgets to object by performance widgets to detail widgets, alert widgets, state widgets or tiles, performance widgets, monitor widgets, object details, and topology widgets. As you can see, the details widget and the alert widget are being used more than once in this set of native dashboard pack. We begin by copying and pasting the PowerShell code snippets from the resource text files and paste it in a new script page in PowerShell ISE here. As you can see here, each PowerShell code section has a description to provide more context on its purpose and functionality. The first command uses the get SCOM management pack commandlet. This is to return all management packs that references the core System Center Visualization Library management pack. This will include the management packs storing the component definition of all custom dashboard and widgets, as shown here. This line returns the full list of getComponent PowerShell methods that can be used to query configuration information of native dashboards. This section uses the getComponentTypes method to return all native dashboard component type entities and their properties. This is the list of their display names. This section uses the getComponentOverrides method to return all native dashboard component override entities and their properties. This is the list of their display names. Now, we count the number of component types found and the number of component override entities found. As shown here, the number of component override entities is way less, only 62, than the number of component types found. Since a component override will only be created when a new custom widget or layout is created in the Operations Console, and that its count is way less than the amount of component types in this environment, the get component override would be the ideal place to start looking to find out more about the custom widgets and layouts in a particular SCOM environment. In this section, the date threshold variable is assigned an approximate date time value, which is the date time of the measurement pack that were the earliest to be imported into this SCOM environment in UTC. Usually, this is during installation time of the SCOM environment. This date time value would be different for every SCOM environment, and you can find it here in install measurement pack, where you see the earliest date imported. This section filters the full list of component overrides to only the ones created post-SCOM environment installation. And look at the display names, right? These are the layouts and widgets created in this sample demo dashboard pack. Next, we directly apply the date threshold filter when running the get component overrides method. For each component entity, we will output its display name, description, and its property values. Okay, PowerShell grid widget in demo dashboard 1. Notice that we can output the PowerShell script used in one of the sample PowerShell widgets in this demo set as is, and other useful values which are assigned to properties of the custom widgets and layouts. This is by drilling further into the binding info property of each component override entity. So the script here is the script used in this widget. And the description is also being returned here. Here. In this section, we will try to calculate the overall top-end widget or layout types used across all custom widgets and layouts in this SCOM environment. Notice that the all component types list is being used, which is an output of the get component types method. The reason is because the only way to find out what type a custom widget or layout belongs to is from the base property of its component type entity. And we use the group object commandlet to count the number of widgets or layouts by their base or dashboard type. So we have got six widgets that are of the generic details widget and 2 widgets that are of the alert dashboard type. But hang on, notice that it's returning a count of 6 for the number of widgets belonging to the details widgets type. This is not accurate as I only have 3 in my lab SCOM environment. Let's have a look. One, 2, and 3. I then recall that I have previously created and then deleted two details widgets while configuring the set of demo dashboard widgets and layouts. And the most effective way to clean up these unwanted widgets is to delete the layout they were initially hosted on. This will remove the layout components and all widget components associated with it. So in this next section, I will show you an approach to filter away the non-active or deleted widgets and only returning the widgets that are currently being hosted by custom layouts. This step here stores the mapping information of each layout cell to their respective widget into an array. Once the array is ready, we can cross-check with the full list of custom or post-SCOM installation created widgets and filter away the deleted ones in this section. Therefore, the top N widget type used in this SCOM environment returned here is more accurate as it only shows 3 widgets of type details widget and 2 widgets of type alert dashboard widget. This concludes my demonstration on how to use the get component PowerShell methods to query configuration information from native dashboard layouts and widgets. Now, we will return to the slides and continue with the next topic of our session. Now, I would like to introduce a custom widget that I have created a while ago called the Speedometer Gauge widget. This widget allows the numerical results calculated from a PowerShell script to be displayed on a speedometer gauge visualizer. The color change thresholds and color schemes can be defined in the PowerShell script. The widget can be configured with PowerShell on a template defined in the dashboard library management pack that I have created. And it can be saved in a custom management pack like any other widgets to be shared or for backup. As shown in this example, the speedometer gauge widget template contains a list of pages to be configured through its wizard. You can enter a meaningful name and description for the widget in the general properties page. A PowerShell script to set the thresholds and color schemes and calculate the value to be on the speedometer. And then configure the refresh interval for the PowerShell script to run. This slide shows the relationship between the controllable parts of the speedometer gauge visualizer and the script context data object properties that will need to be set with the right values in the PowerShell script used in the widget for the speedometer gauge to work accordingly. So I will now demonstrate how to set up the template for the speedometer gauge widget that I just introduced. Now, I will demonstrate how to set up the template for the speedometer gauge widget described in the previous slides. I'm now back at my lab environment to do this demonstration. In the folder I created that contains the resources for this demonstration, I've included the dashboard library pack for SCOMathon 2022, in which it contains the dashboard template for the speedometer gauge widget. We begin by going to the SCOM Operations Console in my lab environment, and in the administration workspace, right-click and import the library management pack into the SCOM environment. Once this management pack has successfully been imported, it can be found by searching in the Management Pack view of the administration workspace. Here, we see that this library management pack has been imported successfully. Next, we have to close the Operations Console and restart it to allow the speedometer gauge widget template of the 2-state and the 3-state speedometer gauge widgets to be properly added into the widget template directory in order for it to show up as a selection when selecting a widget to be added into a cell of a dashboard layout. Hence, please remember to restart the Operations Console right after the successful import of this library management pack for this very reason. As soon as the Operations Console is restarted, we create a management pack in the administration workspace to store the configuration information of the speedometer gauge widgets that we are going to create. Let's call it SCOMathon. (2022) Speedo Demo Dashboards. After creating the management pack in the administration workspace, a folder of the same name will show up in the monitoring workspace. Any dashboards or views created in this folder will be stored in the management pack this folder is defined in. We are going to create a dashboard layout in this folder, which will then be stored in the SCOMathon Speedo Demo Dashboard Management Pack. Let's call this dashboard layout Speedometer Gauge Demo. I will use a 4-cell dashboard layout. Speedometer Gauge Demo, 4 cells. Next. Create. When I click Add Widget in a single cell, the page of the list of native widget templates opens, but this time, notice that there is a custom folder and 2 new templates in the folder for the 2-state and 3-state speedometer gauge widget, which was implemented when we imported the library pack just now. So, we will return to the slides and proceed with the final part of our demonstration. And lastly, I will introduce how to create a dashboard with a 2-state and a 3-state speedometer gauge widget. Now, I will demonstrate how to create a 2-state and a 3-state speedometer gauge widget. Once again, we are back at my lab environment to wrap up this demonstration. Returning to the 4-cell dashboard layout we just created in this folder, we know that its configurations is stored in the SCOMathon Speedo Demo Dashboards Management Pack. We are going to create 2 normal speedometer gauge widgets and 2 3-state speedometer gauge widgets. I will start with a 2-state speedometer gauge widget, which is the normal speedometer gauge widget, using the default settings. When I click add widget in the first cell, the page of the list of native widget templates opens, where I will select the normal speedometer gauge widget option. In general properties, let's call it two-state speedometer static. Click Next into the PowerShell script page. Notice that there is already a sample PowerShell script to help us get started in configuring this speedometer gauge widget. Note that the speedometer gauge is controlled by the script context data object properties in this script. The minimum data object property controls the minimum value on the gauge of the speedometer. The maximum data object property controls the maximum value on the gauge of the speedometer. P is assigned to the format string property to give the output value a percentage symbol. The value property is important as it is the calculated value that will be displayed and move the needle of the speedometer gauge widget. Here it works with just a static value assigned. The goal data object property just displays a static value for the target value on the speedometer gauge. The other four remaining data object properties provides the threshold to change the color of the speedometer depending on whether the calculated value exceeds the threshold or not. In this example, threshold color target and threshold endpoint target specify the color shown on the speedometer gauge as green before the endpoint target value is exceeded, and threshold color full and threshold endpoint full specify the range that turns the color to red if the endpoint target value is exceeded. To verify and determine the color code of choice for your speedometer gauge, you can use the Edit Color feature in the newer version of MS Paint. Here, it will display the color code of the color selected in the color palette. Then we click Next, leave the refresh interval value as is, click Next, add an additional note for reference, and click Create. As soon as the widget reloads on the first cell of the dashboard, you will see the results of the PowerShell script displayed on a speedometer gauge. Now, I'm going to repeat the process to create a 3-state speedometer gauge widget. I will click Add Widget. In the second cell, select the 3-state speedometer gauge widget option. In General Properties, let's call it 3-state speedometer dynamic. Click Next into the PowerShell script page. Notice that there's already a sample PowerShell script available, just like the 2-state speedometer gauge widget. However, there are two additional object properties: the threshold color mid and threshold endpoint mid, to account for a warning or mid state that will change the color on the speedometer to yellow. This time I'm going to use a getRandom commandlet. and assign a random numerical value that is between 1 and 99 to the value data object property at every refresh of the widget. Click Next. Set the refresh interval value at 5 seconds. Click Next. Add an additional note. Click Next and create. And as soon as the widget reloads on the second cell of the dashboard, you will see the results of the PowerShell script displayed on a speedometer gauge based on the random value obtained. And it moves the needle every 5 seconds. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And change color accordingly to the color threshold range set in the PowerShell script. For the remaining 2 cells, we are going to use a PowerShell script that I prepared up front, which is located in the resource folder. This script retrieves the average total CPU usage over the last few hours from an object of the operating system class. We will use the management server as the example. Okay, back to the operations console. We will name the third cell as 2-state speedometer MS percentage CPU and paste the PowerShell script from the file into the PowerShell script page of the speedometer gauge widget. Leave all settings as default and click Create. Next, we will name the fourth cell as 3-state speedometer MS percentage CPU. This time, in the PowerShell script file, we will only copy the top part before the data object properties to control the speedometer gauge. And paste here in the PowerShell script page of the 3-state speedometer gauge widget. We will leave all other settings as default and we will click Create. And now we have a SCOM native dashboard with 4 cells, all hosting speedometer gauge widgets, displaying the numerical results calculated or specified in the PowerShell script and moving the needle or dial on the speedometer gauge within the range specified and changing the colors based on the thresholds set. Hope this demo is helpful in showing you how easy and straightforward it is to configure a speedometer gauge widget with this template. This concludes my demonstration on how to create a dashboard with a 2-state and a 3-state speedometer gauge widget. Let's return to the slides and go through the post-demo notes. This concludes the demo section on the PowerShell methods for native dashboards and the speedometer gauge widget. All samples from these demos will be shared. These include the sample community MP file with the speedometer widget templates for 2-state and 3-state speedometer widgets, a how-to guide to configure the speedometer gauge widgets in PDF format, and a copy of the PowerShell scripts used for the speedometer gauge widgets. Also, a copy of the PowerShell script used with the methods to query native dashboard configuration and information. In summary, there are many ways in SCOM to display and visualize data using built-in features like views, dashboards, reports, and external tools like Power BI. Depending on how interactive you want the visualization experience to be, and how much historical data is required to be displayed, or how close to real-time the monitoring data is displayed should be. SCOM native dashboards and widgets provide a cost-effective way and a good balance between interactivity and allows monitoring data from different sources and time range to be accessed and displayed in different formats. And with the right PowerShell commandlets and methods, we can identify management packs with custom native dashboard widgets stored and implemented in a particular SCOM environment. We can use these PowerShell methods to query the configuration information of these custom native dashboards and widgets. This information can be very useful to identify important widget assets when planning to migrate or upgrade to another SCOM environment, or planning to integrate with other dashboarding solutions or automated systems. Lastly is the Speedometer gauge widget introduced in this session. It allows the numerical result calculated from a PowerShell script to be displayed on a speedometer gauge visualizer. The color change threshold and color schemes can be defined in the PowerShell script. This could be used or projected on a large screen in a network or monitoring command center, where the gauges will turn and potentially change color based on the results calculated at a predefined frequency. So everyone, thank you for your time and your support, and I'll see you over at the Meet the Speaker Cafe to chat with you and to take further questions. Enjoy the rest of the sessions in this awesome virtual event. Thank you very much, and bye. Take care.